Hi and welcome back to my Salvage BMW Rebuild. So in the last video we discovered the reason for the seized engine. If you missed the engine strip down video, I'm going to link to it now at the top of this video. Some of my viewers actually told me it was the best video in the series yet, so you won't want to miss it. So in this video we're going to investigate further, is this the only problem? The crank's not looking like it's damaged, so that leaves really just the rest of the pistons and the rest of the Conrods to investigate. But how wrong I was. Later in the video I find a serious problem. Now the problem with fixing salvage cars sometimes is knowing how far to go with it. Yes, you want to do good repair, but you can turn it into a big job and also make it more expensive than it needs to be. And that's why I've been looking for a possible way of diagnosing if there's a problem with these pistons and conrods without stripping the engine down further, because I could take the crank off of the bottom, take all of these pistons out, only to find they're okay. When you get a bent conrod, the piston gets shorter. What that also means is the piston won't come up to the top fully. One of my ideas was to measure how far from the top the pistons come and check all three of them, and if they're all the same and they're all coming up to the same level, then chances are none of them are bent. So I'm going to use a DTI to measure when the cylinder's at the very top of its stroke. And then I'm going to use a dial caliper to measure how far down the piston is from the top of the block. As that pointer moves up and down, you can see the number changes. What I can do now is I can turn the crank, get that number to the highest that it's going to go to. And when it's at the highest it reads, then I'll know that piston's right at the top. And I'm going to turn the engine only clockwise. No engine likes to be turned backwards, you can have problems. And you'll notice I'm just using a little ratchet, and that's because there's no compression on the engine with the head being off. This should turn really easily. Okay, so the problem is not really a perfect solution this for turning a crank. There's all these little Torx bolts in there and this socket fits onto it, and so it tends to slip off quite easily, especially if the engine's just a little bit stiff, which it was just then. So I'm just kind of going to nudge it along slowly now. Oh, going up. So that means the piston's coming up. Okay, I'm happy with that. And now we can be sure the piston is absolutely at the top. So what I've done is I've cleaned the part of the piston in the top of the block there. And this is where I'm going to take my measurement with the vernier now. I'm trying to keep this as square as I possibly can. That's 0.7. You might be asking why I'm not doing the measuring with the DTI, and the reason is I would now have to change it from that cylinder to the other, which basically means re-zeroing it again, which makes it really hard for me to compare one to the other one. So I'm going to go ahead and measure the other two, and we're going to see where we are. As near as I can measure and test with the equipment I've got, all three of these cylinders are coming up to the same level, which means the conrods are all the same length, which means they're either all bent or none of them are, and I'm going with none of them. In the meantime, a used replacement piston arrived, but it's really dirty. So I decided to clean it up using an ultrasonic cleaner. I don't have any special cleaning fluid, but I do have some degreaser, so let's give that a try. I don't know much about ultrasonic cleaners, but 40 degrees C seemed like a good temperature for the water and the degreaser. And apparently a frequency of 40 kilohertz is less likely to damage delicate components. So I set it going for 25 minutes and we'll come have a look and see how clean it is. So it has lifted some of it, but there's still some in there. So I'm just going to give it a little scrub, just have a brass brush, because the ultrasonic cleaner has really softened all of this. So the new piston came out really well, so I put it on the radiator to dry. Thanks again to my very understanding wife. Okay, so big thanks to my friend Steve for the loan of his ultrasonic cleaner, because just look how nice the pistons come out. And let's just have a little look at it on the bench. So hiding over here is the old bent conrod that we're replacing. Here's our new one, nice straight conrod, so that's always a bonus, isn't it? And apart from cleaning up the piston, there's a few things I'm going to make sure that I get right. So in a minute I'm going to clean up inside here just with some oil and a clean cloth, because I don't want any grit in there, because that's where I'm going to put the bearing back in. The other thing to notice is that the clamp that holds it onto the crank, this has to go in the right orientation, and that's because these are something that's called fracture split. So this is all forged as one piece, and then probably in a very precise way they hit it, probably with a pointy pin of some kind, and that causes a fracture, and then this piece comes off. A bit like if you knock one of your favourite ornaments off of the mantelpiece and you glue it back together again. when you look at it, you can see all the craggy fractures, but when you push it together in exactly the right place, it becomes seamless. So of course it wouldn't work if it was the other way around. So I have to make sure I do that right. And then the final thing is, usually you have a couple of piston rings and then you'll have an oil scraper. There's a very specific place where the split in the ring, which is just here, it's hard to see on the top one. And then normally your second ring, you have to make sure it doesn't line up, because otherwise your compression, your combustion gases potentially could have a path through. So that one would be rotated to a new position. Normally I would say 180, but I think in the BMW technical manual it's saying 90. But we'll get to that in a minute. And then finally the oil scraper, there has a top one, a bottom one, and then a bit of a webbing in between. And so you can actually offset those into a different position from the piston rings as well. Another thing to say about these rings is sometimes they're profiled. So they'll be profiled different on the top edge of the ring than they will to the bottom. So if you take them off, it's always worth taking note of which way up they were, as well as which slot they were in, to make sure it goes back how it should. So I'm just going to use some light oil and a little bit of wire wool, and I'm just going to clean up the surface of this ring. Piston rings are made of hardened steel, so I'm not worried about damaging it. And then I'm just going to give this a clean up with a bit of brake fluid. So I just noticed that the top side of the ring has a little bit of engraving on it. You won't be able to see it on camera, but it means that I know which side is the top side. Anyway, so the reason why I've got both of these off, of both pistons, is because I'm going to use the best one. So there is a way of measuring these and seeing which one's got the most life left in it, and I'll show you how to do that now. Okay, so as you can see, I've brought one of the pistons up to about 3/4 of an inch, or about 20 millimeters from the top. And that's because in a minute I'm going to put a ring in, and the piston allows me to sit the ring in against it, meaning that it's down evenly all the way around. I'm just going to grab the piston ring, and I'm going to put it down into there, and I'm going to push it all the way down until it's touching the piston all the way around. So I hope that you can see this, but where the two ends of the piston ring meet, then you can measure that now, and that's called end clearance. And it'll be small. It'll probably only be 0.2 of a millimeter, something like that. So I've got a set of feeler gauges, and you can see I've selected the 0.2 millimeter feeler gauge. And I'm just going to check to see what that gap is. A little bit awkward. In fact, these won't do it, will they? I think one of the reasons why I'm struggling is because the piston's so far down. So I'm just going to bring it up a bit. Come back with my feeler gauge. So that gap is less than 0.2 of a millimeter, and that's as low as these feeler gauges go. But I do have another set that go down smaller. So for example, this one here, that one, if I can get it on its own, is 0.1 of a millimeter. So let's see how that one does. So that'll go in the gap quite easily. So that means the end gap is between 0.1 and 0.2. So end clearance measuring can get a bit laborious, and I don't want to bore you, but basically all you do now is you just move to the next feeler gauge along. So we know it's between 0.1 and 0.2, so now I've got a 0.15, and I'm going to see if that'll go in the gap. And what you're looking for is an interference fit, where you can feel it go in, and it's just a little bit tight but not too tight, and then that will be your measurement. And that's about it, to be honest. And you get a bit of a feel for it. So I would say that the end clearance on this ring is about 0.15. And all I'm going to do now is repeat the process on the other ring from the original piston. So I'm just going to pop that one out, and I'm going to pop that one in exactly the same position. Now, as I suspected, this 0.15 won't go in. So that means this end clearance is much tighter on the original piston. And that's what I thought, because these rings are off a lower mileage engine. So I'm going to use all of the rings off of my original piston into the new piston. Get that assembled, and then we can install it. Earlier on in the video I mentioned that when you install the rings, they have to be offset to each other. So this is the 12 o'clock position, the 4 o'clock and the 8 o'clock. What you normally do is, if these are a 3-piece system for the oil scraper ring, then you put the mesh in first. And the mesh can go with the gap between the pieces at 12 o'clock. And of course it goes into the very bottom groove because it's the oil scraper. And now the lower ring, the gap, we're going to put it 4 o'clock. So just going to pass that over all the way to the very bottom. Okay, and now we just need the upper scraper ring. And you guessed it, the gap for this ring is going to be at 8 o'clock now. Okay, now it's time for piston ring 2. Now both of these piston rings, BMW ones, they have engraving in the surface. I'll bring it as close. Oh, you can just see it, yeah. And the technical manual says the engraving has to face upwards towards the combustion chamber. And this second ring, it's out also stepped, so it's not of a square cross section. So if I just draw it on here for you, then the cross section of the ring is like this. So it has a step in it, and the step has to go down towards the sump. And it will, as long as you make sure the writing is facing upwards. It's worth mentioning that I'm wearing glasses while I'm doing this because these can be brittle and suddenly break. So it's a sensible precaution. So when we're installing this second ring, we're back to 12 o'clock again for the gap. Okay, gap's at 12 o'clock. The final one, the gap is at 4 o'clock again. And there are special piston ring pliers that you can buy, but I don't see why you need them, to be honest. Okay, so we're almost ready to install this piston, but what I'm going to do now is just put some light oil on the rings all the way around. You can use engine oil. I just had this to hand, you know, and just on the outer part of the piston as well. So in order to install this, you have to compress all these rings because there's not much clearance for the piston itself, let alone if the rings are fully expanded like they are here. And all you do is you fit that over your piston, and then you just use a ratchet to start tightening it up. So I'm going to take the slack out of it, and then I'll show you how I like to position this onto the piston. Okay, so that'll do for now. So what I like to do is I'll slide this ring compressor up. So I get about ½ an inch, or about 12 millimeters, up from the bottom, and then tighten it up a little bit more. Now what you want is the ring compressor to be snug, so that it's fully compressing those rings. But you don't want to really lean on this and make it super tight, because in a minute we're going to insert that into the cylinder, and as we tap the piston in, then this starts to slide off of the piston, and if you get that incredibly tight, then it's not going to want to slide. So I'm ready to install this piston, and the only final thing is there's a little arrow engraved in the top of the piston, and it has to point in that direction. Now I've got 3 other pistons, so of course I can look at those for reference. Almost forgot, I want the crank to be at the bottom position, and that'll give the most room for the Conrod to go down without interfering. Okay, that'll do. Stop the action. So when I was looking down in there ready to insert the piston again, I saw something down on the crank that I didn't like the look of. Originally I expected to drop out the crank and inspect it fully, but I spun it over a few times and looked down the cylinders and I thought it looked okay, but potentially this doesn't look okay. So I'm going to get the GoPro on the job and I'm going to show you what's concerning me. So can you see down at the bottom on the crank, it looks like there's a scratch or maybe a crack on the crank where the bearing would normally sit. So I'm going to need to investigate that further. So I'm going to take another piston out. I'm pretty sure it's not normal what I've just seen. But if I check another area of the crank and it looks completely clean, which is how I think it should look, then it suggests that there's a problem on the crank. And this of course is piston 1 where we've had the bent Conrod, so some of that force might have been transferred to the crank. Okay, so I'm just taking a second piston out. I've already unclamped it from the crank underneath and pushed it up a little bit. So now it's ready just to grab out and slide out of there. And now I can just turn over the crank and rotate that. And I'm just checking that there's not a mark on the next piston across in a similar way, just to see if it's normal or not. But what I've seen before, the crank where the bearing goes has always been flawless and clean. No, that's how I would expect it to look. Completely clean down there. The crank does look suspect on cylinder 1, so I'm going to take the rest of the pistons out and we'll see if we can get this crank out. Okay, so up to now we've had it easy because cylinder 1 and cylinder 2 we can just access the Conrod bolt super easy. But here cylinder 3, as you can see, okay, we can still get to it, but it's getting more difficult. But number 4, it's impossible because it's behind this, which is the oil pump. So the next step to get the rest of the pistons out is to remove the oil pump. So this here is a little Torx bolt that holds on the sprocket for the oil pump, and the chain is driven by the crankshaft, which is a bit higher up. So we need to take that off first, And then once that's slid off and the chain's off, it's going to be pretty straightforward to do the bolts for the oil pump after that. Of course, BMW specifies a special tool for doing that, but in reality it's a T45 Torx. The problem is the access. What I've got is my little T45, which I can just get in. And what I'm going to do is I just have a ring spanner here, because you can see it's a hex at the end. But I'm not buying a special tool for this one bolt. And I'm just going to see if I can shock this loose now by hitting it with a hammer. Just a final thing to say is this is left hand thread, so I'm going to be turning this clockwise, which would normally be tightening, but not for this one. There we go, I think I got it. Quite a long bolt, isn't it? One thing to note is this thread is completely clean, no Loctite on it. And now this sprocket should just slide off, and it did. It just sits on that little collar there, you see. And I'm just going to take note that the writing on this pulley was that way facing towards the flywheel for when I'm refitting it again. So there's just a couple of screws underneath where it's a little bit harder to show you. So I'm going to do those first. So as you can see, that's a lot better now. That's number 4. Number 3 is just up there, but the access is much better. I'm going to loosen those now, but then I've changed my technique slightly. So what I plan to do is loosen those and then rotate the engine to move that piston as high up as possible. Because before I've been driving the piston out the top, and it's been, you know, had to drive it quite a long way. Whereas if I've rotated the engine and it's already almost at the top, then the piston will almost be out already. So let's get this loosened off. I need a small extension. Just going to rotate that up to the top. Go ahead and spin those out now. So that's come out with the bearing. So I'm going to use my bit of plastic just to drive that up just a little bit. Okay, so that's number 4 out. Next up, we want to remove this pulley because that's the one on the end of the crank and it fastens to the crankshaft. But you can see the belt still in place. Now over here, this is the tensioner for the belt and there's a big spring behind. So you just get the right size spanner, in this case it's a 16mm. Take the tension off the belt. Let's see, I should be able to get it off one of these. There we go, just like that. Now I'm not going to remove this just yet because I still need those screws in there because they're what the tool fits on, which is allowing me to rotate the engine. Can you see these other bolts in the background? Well, these hold the torque converter on. I can get to a couple of them right now, but soon I'll have to rotate the engine in order to get to the other ones. Now I'm pretty sure the torque converter won't come off the front while the engine's on the stand, but we'll worry about that later. As you can see, I can rotate the engine easily by hand from this end. So maybe I could have taken that pulley off. All I'm doing at the top is I've got a screwdriver and I'm just putting it into one of the teeth and I'm stopping the flywheel from rotating. Otherwise it just keeps spinning instead of these nuts coming undone. They're not that tight, so I'm not that worried about damaging a tooth on the flywheel. Okay, so it feels about the right time to get this pulley off now. So I just have to undo each one of those 4 bolts in there. You can see that pulley's just loose, so as this last bolt comes out then it'll just come right off. Very different to the type that were on tapers where they'd really get wedged on. Okay, let's go ahead and get these torque converter bolts out, and in a minute we're going to have to suspend the engine so I can get the torque converter off the end of the crankshaft. These are all the nuts we couldn't get to ages ago, right at the beginning of the job, because we couldn't turn the engine. I'm just going to leave a couple of nuts just on a little bit because I don't want this falling on the floor. So the engine's not very heavy now because so much has been removed from it. So I'm just going to put rope around it a few times Just going to take the weight a little bit. It's a lot of messing around this, isn't it? You know, when you just want to repair the engine. Okay. So I'm just going to temporarily take this mounting plate off, and then that will allow the torque converter to come out. I don't like working on an engine suspended like this, so you just have to be careful not to go under it at any point. But I'm going to keep my distance, and I know I just have 2 bolts on the torque converter around the back. These things can be heavy, by the way. I've got it. Let's get it back onto the stand as soon as possible, because I'll feel a lot safer that way. So I've just got some grease. I noticed it was awkward, you know, tight to turn and awkward to slide off. So a little bit of grease will probably help that. This was a little bit awkward last time I did this, so I imagine it'll be awkward again. Oh, a lot better, huh? So we're ready to undo the flywheel now. It's all these bolts around this side where the torque converter was a minute ago. The problem is this just moves so easily. BMW, of course, sell a special tool that locks this flywheel and allows you to get those bolts undone. I don't have it, and I don't want to spend the money on it, so I've come up with this ingenious, well, I think it's ingenious, little fudge tool. Let's see. And as you can see, it's nothing too fancy, it's just a bolt I've put through. Now, what I have to be careful of is when I start turning the nuts on the other side here, this is going to spin. These will come up against here, which is fine, but these are aluminium or aluminum if you're in North America, and of course this is steel, so that'll damage that. So I need something there, a packing piece, to protect that, and I've got just the thing just here. I'm going to put that there, and I don't want it falling off all the time, so I'm going to attempt to tape it in place, which may or may not work. Okay, that looks pretty good, doesn't it? Just get you guys back over here where the action is. Just see how tight these are. Hopefully not too tight, huh? Oh, there is a loosening sequence, believe it or not. So it's just opposites. So I've done that one there. So I'll go opposite it here. Just a few turns. And then left and then right. Now that I've got those all cracked loose, I should be able to just go ahead and remove these now. They feel quite tight, like maybe they're Loctited in. So this could take a while. So I'll probably speed this up for you guys and maybe even put some nice music on. You see, so just as I thought, there's Loctite on those threads. You can feel it because the bolt, you have to unscrew it all the way out with the ratchet. Yeah, literally have to unscrew these all the way. And as you can see, this flywheel's pretty loose. It just sits on this little hub here. So it shouldn't just fall off, but it will come off very easily once the last bolt's out. I'm just going to hold on to it because these outer teeth are hardened steel, which means they're hard but brittle. So if this falls onto the frame down there, it might snap a tooth off. Right, there we go. Just a couple of things to note. The writing on the outside faces towards us when we're refitting it again. And also the flywheel has a little hole here, and that's a locating peg which is just here, so it can only go in one position. So that's good, I like it when it's like that. This here I understand is some kind of mag drive, or it's a cover that's covering the mag drive, I don't know. It also fits on the peg. So I just read in the technical manual that this is a magnetic drive of some kind, and so the recommendation is to put it in its own plastic bag, and that'll protect it to stop it from attracting metal shavings and swarf. So there's just a few things that I left in place because, to be honest, I thought I was just going to replace one piston in Conrod and then it'd all be going back together again. As you know, it's turning into a bigger job. So one is the aircon compressor, the other is the alternator just here, and then just a few of these remaining hoses and pipes, which, to be honest, there's only a few clips holding them in place, so I might as well get them all off there. And I feel like maybe I'm saving time by leaving them there, but it's costing me time every time I'm turning the engine over and trying to work on it. So we'll start with this electrical connector to the compressor. Just a couple of bolts that secure the aircon compressor onto the engine. Make sure I'm not going to drop this because they can be expensive things, aircon compressors. Come on. It's being a pig, is this one. There we go. Ooh, No dropsies. Next up, the alternator. Electrical connection. This part here is the belt tensioner which we worked on earlier. It bolts onto the front of the alternator, but they should both come off together. Now that's tricky, isn't it? So maybe this belt tensioner does have to come off the front first. So I'll do that first. So let's pop those off. Where were we? Okay, that's right. We were trying to get to that bolt, weren't we? Don't want any alternator dropsy either. They don't normally just fall off, but you never know, do you? There we go. And another area that I should have tidied up a long time ago. Every time I turn the engine over, these hoses and cables flop all over the place. And to be honest, there's only a couple of hose connections left and a couple of electrical ones, so I might as well just get that off and it'll make it easier to work. Just a wire to pull back on this one and a wire to pull back on this one. And then they can be a pain sometimes, but oh, that wasn't too bad, was it? Wiggle that free. Right, okay, so as you can see, we're getting there now. So let's get it done. There's 5 electrical connections. And just a couple of clips. That's one. This one's more of a push tab thing. Oh, that's so much tidier. That's more like it. So we're ready to get the crank out, but the crank won't come out unless this end plate, this is actually an end plate on the block, believe it or not. You can just see where the 2 pieces join. This is bolted through and bonded on. And once again, this is the side that I'm using for my engine stand, so it has to come off the stand so I can get this end plate off, and then potentially I can put it back onto the stand again, but we'll have to see, because I'm getting a bit fed up of it going on and off of the stand. Maybe I'll get this thing up onto the bench where I can mess around with it, because it's a lot smaller now and more manoeuvrable. Okay, so to get to this end plate, we need the engine up on the bench. I prepared a nice surface for it here. I'm sick of getting the engine hoist out and messing around. So I think this engine's light enough that I can just deadlift it up onto there. So let's give it a go. What could go wrong, huh? Where's a good grip? Okay, here I think. Never in doubt. Don't know why I didn't just do that with the full engine, huh? In the first place. Been a lot easier. Okay, so once again, I need to get these bolts back out so I can get this off of the end. Okay, come a bit closer. So there's a whole bunch of little torque screws all over the place, to be honest, so gonna get all those out first. Just gonna loosen on them all first. These only really secure the end plate onto there, while the Loctite, I believe it's bonded on with Loctite, goes off. This could be tricky to get off the end here, and it doesn't show it in the technical manual being removed, so we'll see how we get on. Now I know this end plate won't just fall off, but I can't resist just giving a little pull at it. Who knows, I might be lucky, huh? Okay, so the key thing is I need to lever this now, but everything's aluminium, so it'd be so easy to damage this. It's kind of finding the right way of doing it. There's a little edge behind here and at the other side where I might be able to get a lever in, so let's have a look at that. Don't want any mistakes. Oh, that did pop loose a little bit. I'm just going to tap on these outer edges with a mallet, because who knows, you know, it might free it up a little bit. Actually, it does sound like it might have done a little bit. Oh yes, now that surprised me. Well, something's got to go right, huh? I'm going to hold on to this. Look at that. It's genius. Next up, these two chain guides, they just slide off, and I'm only taking them off for safekeeping so they don't fall off and get damaged. That's one of them. That's the other. And then this chain which was driving the oil pump, this just comes up and over this edge. So again, I'll just keep this safe for now. Bag it and tag it. Okay, so here's where we're at with it. So cylinder 1, which is at the back, is at top dead center. I've just done that by eyeballing it. So I've literally looked down, rotated the crank, and got it so that I think the bearing for cylinder 1 is right at the top, which at the moment's the bottom because the block is upside down. And the next step in our project is the balance shaft, which is just here. This needs to undo. But of course, as soon as I started trying to turn that, then the engine would rotate. So I need something to hold that. And I expect that I'll have some timing tools for this when I put it back together again. But just in case, I've done some markings on the gear wheels, which give me some guidance on where these things go back again. So this one here is the intake balance shaft that I was talking about just a minute ago. Can you see there's almost like a little flat on the balance shaft there? So what I worked out was 13mm spanner goes on there, and that can stop that from rotating, you see, if I just hold it nice and tight. So I have no idea how tight this is going to be, but I'm hoping that just a ratchet and then holding on to this will be enough. It's not. Typical, huh? Alright, let's see what else I need to do. Okay, this might look like overkill, but I've got a bar on there which is holding the spanner. Jeez, that's tight. Looks like it wants to up the ante a bit, huh? I've got a longer bar now. I think I've got it there. Just a lot tighter than I expect it to be, that's all. Now this bolt's loose on this side, so I can just undo it by hand. But I'm just holding the balance shaft in at the moment because apparently there's a couple of needle bearings and you have to guide it out pretty carefully out of those. Okay, so that's come off of that side. Okay, so now the balance shaft will slide out this way. These are the needle bearings that I'm being careful of here while I'm sliding this out. This is one of the jobs where you feel like you need more hands than you've got. I don't think I have to remove the entire balance shaft. The problem that I've got is this crank won't lift out because the balance shaft gears are holding it in place. So you should just be able to see here that because this gear's moved about an inch that way, it's no longer engaged on here. So it's no longer holding the crank in place. So that's good. Now there's like an intermediate gear on this side. So the balance shaft on the exhaust side is lower down. So it has like this intermediate gear which drives the balance shaft. So this one needs to come out as well. Okay, so this here is the nut on the transfer gear. It doesn't turn with the gear. So we don't have to secure the shaft to stop it spinning. We can just work directly on that. See how tight this one is, huh? Okay, not too bad. I'm just going to spin that loose. And straight away this gear is floating a little bit. I think that this intermediate gear has to come fully out. Okay, so there's nothing on this gear system that's holding the crank in now, so now I can work directly on the main bearings. And there is an unfastening sequence on these. So the central one, then this one, then that one, then the far one, you got it. This is the problem, you see, the block just slides around. Those are tight. No, I mean really tight. Let's see if I've got any more leverage to be had. I think that I need an impact gun, don't you? It's just something I've never used a lot, to be honest. I always think that these are quite delicate components for sticking an impact gun on. So I've got some tube, which I had earlier, which is great for this, but then I need to stop this from sliding around still. So I don't know how I do both. Maybe if that's up against the wall, the engine can't turn, I don't know. But you never realised those things were on as tight as that, did you? And so one half of the bearing is inside there, and it should be in pretty good condition, but I won't be using it again because these are matched to the crank, and remember we're going for a replacement crank. I'm just going to repeat that process for the rest of these bearing caps, so rejoin me once I've done that. Okay, so this is the last of the main bearings coming out now. Put it over there. And then the theory is this crank just lifts out. Now it might look small, but these things are a heavy lump. So I need to make sure I get a really good grip on this. Now finally, I can show you properly down on bearing 1 what my concern is and why we're getting a replacement crank. So basically that's it. All of that line that's on the bearing, including that kind of U-shape or whatever it is, you know, that just shouldn't be there. So I don't know if that's a stress fracture, a crack, or just a scratch on the bearing, but it shouldn't be there, so it's enough to make me want to replace this crank just to be safe, because as you've seen in all the videos, it's a massive job just to get the engine out and stripped down and working on it. I don't want to be doing it again. So a bit of a different video to what I intended when I started this one, because I thought it would be about rebuilding this engine, not stripping it down further and finding more problems, but this is the reality. But I hope that you're enjoying these videos, and if you are, then please give me a thumbs up. And if you saw anything in the content that you have a question about, then please drop it in the comment section and I'll answer those. And if you're not already a subscriber, then please consider subscribing. I promise it's going to be engine rebuilding in the next video. Okay, thanks for watching. Bye for now.